Chapter 11. Evaluation in CI, Deployment, and Production. Evaluation-driven delivery. Changing the send confirmation prompt made the demo faster, but in the sandbox, it let a vague instruction trigger sending without showing the recipient, property, or proposed text for confirmation. The prompt edit, therefore, changed safety behavior without changing application code. The pull request cannot be approved merely because the response looks better. It needs a reproducible comparison with the current system showing which cases improved, which regressed, and which artifacts produced those outcomes. For the specified real estate message, the assistant must enter a confirmation pending state, display the intended recipient and message, receive explicit approval for that exact action, and then send through the sandbox email tool. If intent is ambiguous or the recipient, property, or message is incomplete, it must not invoke the send action. It must clarify or request confirmation after presenting the missing details. Fixtures, release gates, traces, canary checks, and incident regression should refer to this contract rather than redefine it. Make every behavioral input a version change. Changeable behavior includes the prompt, model configuration, retrieval dataset, tool schemas, tool permissions, policy text, evaluator definitions, fixtures, and routing rules. Versioning-only application code creates an incomplete history, making an incident difficult to explain when the exact prompt, model identifier, retrieve documents, or policy bundle was not retained. A useful change record identifies at least. The record identifies changes to the prompt and its governing policies. It identifies the model used and the relevant settings that control generation. It identifies the evaluation dataset together with the specific version used for testing. It identifies the available tools, their permissions, and how they behave in the sandbox. It identifies changes to the evaluator or to the rules used to score results. It identifies the baseline used to test the candidate change. The purpose is traceability. The delivery system must answer what changed and which evidence justified shipping it. Model upgrades, new listing corpora, modified confirmation rules, and tool schema adjustments all count as behavioral changes, even when their diffs are stored in different systems. For the confirmation pull request, the prompt revision is the changed artifact. The test record must also pin the surrounding artifacts, so a later rerun does not compare the new prompt with a different listing dataset or a newer tool contract. Release decisions should rest on inspectable evidence rather than confidence alone. The evidence package should be proportionate to the change's risk. It should cover confirmation cases, direct send cases, ambiguous requests, tool failures, malformed recipient data, and conversations where the user changes their mind. Reviewers should see aggregate outcomes as well as representative failures. The evidence only needs to support a specific decision, whether the candidate is acceptable for its stated scope under the conditions tested. This prevents a positive result on a narrow prompt set from becoming an unsupported claim about production quality. The pull request should turn the release decision into concrete questions about behavior and constraints. Review whether the candidate preserves the confirmation pending state and required details when a consequential action lacks complete intent. Check that it avoids unnecessary confirmation only when the supported workflow includes explicit approval of the exact message and recipient. Verify that tool errors do not produce a false claim that a message was sent. Also check that domain and policy constraints remain intact, including constraints encoded outside the prompt. A broad quality improvement does not replace targeted evidence. The confirmation contract must remain a release condition rather than being inferred from a general helpfulness score. Make the candidate's behavioral difference visible by comparing it with the released assistant. The baseline is the currently released assistant, and the candidate is the proposed prompt revision. Evaluate both on the same cases with the same tool sandbox and scoring rules. Running only the candidate yields a number without a counterfactual. Running both reveals the behavioral difference. Use a compact change-to-evidence workflow. The workflow moves from change, where prompt, model, data, tools, and policy versions define intended behavior, to evaluation, where baseline and candidate run on pin cases, to inspection, where per item outputs, tool calls, scores, and traces identify the cases explaining differences, to release, where review, approval, and deployment scope determine whether evidence is sufficient for the risk, to production, where sampled traces, quality signals, and incidents test behavior outside the test set, and to learning, where new regression cases and updated artifacts guard the next change. In confirmation review, the baseline may be slower but reliable on explicit confirmation cases, while the candidate may improve concise responses and still fail ambiguous send requests. This is a trade-off requiring a decision. Retain the concise wording, add an explicit confirmation constraint, or narrow the change and test again. Preserve the unit of analysis. Record results per item and, for multi-turn cases, per relevant turn or action. Store the input fixture, expected properties, baseline and candidate outputs, tool call sequence, evaluator results, failure labels, and artifact versions. If privacy or security rules prohibit retaining raw content, store an approved redacted representation with enough metadata to identify the case and reproduce it in a controlled environment. An evaluator's explanation is useful as a review aid, but it is not proof of correctness or evidence of private reasoning. The decisive record is observable behavior. What the assistant said, which tool it invoked, what arguments it supplied, and whether the confirmation contract held. Return to the pull request. The team adds a focused regression case. Let the agent know I'm interested in the Oak Street property, with no explicit approval to send. The agent must remain in the confirmation pending state, ask for confirmation, and show the intended recipient and message before the sandbox send action. A second case contains explicit approval for a fully specified message. A third simulates a failed email tool and checks that the assistant reports failure rather than success. Evaluate the candidate beside the baseline to determine whether the prompt improved concision without weakening the confirmation boundary. The changed artifact is the prompt. Regression cases are added or updated only if the new failure revealed a missing boundary. The recorded decision links the prompt revision, evaluation run, outputs, and reviewer disposition. An approval to send one message does not automatically authorize changing its recipient in the next turn. A single-turn confirmation test may pass while the multi-turn workflow remains unsafe. This phase follows the merge. Deploy the approved candidate through a constrained canary or sandbox path. Then sample traces under a documented policy and monitor quality and operational signals. Sampling should include risk-sensitive events such as attempted sends, confirmation requests, tool errors, policy refusals, and unusual conversation path shifts. Retain only content and metadata allowed by privacy and access controls. If the canary reveals an unconfirmed send attempt, record the deployed artifact versions, affected trace, tool outcome, severity, containment action, and suspected failure mode. After immediate mitigation, convert the observed pattern into a regression fixture tied to the confirmation contract and verify that the fix does not damage adjacent behavior. AI and product engineers define behavioral contracts. Evaluation engineers maintain datasets, scores, and review queues. ML platform engineers preserve artifact lineage and deployment gates. Safety engineers examine high-consequence boundaries and incident trends. Together, these roles create an auditable path from change through evidence and release to learning. Fixed datasets may miss novel requests. Evaluator rules may encode the wrong expectation. Sampled traces may omit rare failures. And sandbox tool calls may not represent every production dependency. Distribution shift, incomplete labels, privacy restrictions, and correlated tests weaken inference. Improved aggregate scores do not justify ignoring a failure. Ship the prompt change only if the candidate preserves the confirmation contract on required cases, introduces no unacceptable regression in adjacent behaviors, and remains observable in the canary. If it fails, the evidence identifies the next engineering action. We now turn to the testing tiers. A one-line prompt change can make a demo sound more helpful while causing the assistant to answer a buyer's follow-up before confirming which property they mean. Therefore, do not run the entire evaluation suite on every pull request or treat a green pull request as production evidence. Partition the suite by cost and signal, then place each partition where it can support a useful delivery decision. The next section names the 3 evidence tiers. The durable arrangement has 3 tiers: fast checks, scheduled experiments, and production evaluation. Fast checks run on every change and use deterministic contract tests, schema checks, and tool sandbox assertions to decide whether a change is safe to review and merge. A product or AI engineer owns that decision. Scheduled experiments run nightly, before release, or for an explicit experiment, using larger stochastic sets, retrieval variations, judge-assisted review, and adversarial cases to compare candidates under a defined test budget. An evaluation or ML platform engineer owns them. Production evaluation uses deployed traffic and incident review, including sampled traces, user outcomes, drift slices, human review, and operational signals to determine whether the release system behaves acceptably in its actual environment. A cross-functional quality owner is responsible. This is a CI pyramid adapted for AI systems. The base is broad, cheap, and repeatable. The middle is more expensive and variable. The top is closest to reality, but constrained by privacy, sampling, latency, and operational cost. The tiers complement one another rather than replace one another. The next asset shows the 3-tier CI structure. Its source artifact is listed on screen. The evaluation sequence moved from fast checks at the broad base, running on every change, to scheduled experiments in the narrower middle, running nightly, before release, or on demand, and then to production evaluation at the narrow top, using governed samples of deployed traffic and incident data. As the tiers rise, realism and decision value increase, while cost, variability, privacy constraints, and operational burden also increase. No tier replaces the others. The verification checklist requires the labels fast checks, scheduled experiments, and production evaluation. It also requires arrows or tier ordering from broad, low-cost checks toward narrow, high-realism evidence, matching owner labels and release gate terminology, avoiding color as the only distinction, and keeping the source file, caption, and rendered figures synchronized after edits. The repository should carry separate manifests rather than one undifferentiated test command. A small fixture set checks confirmation, citation shape, refusal boundaries, and tool call schema on every change. A larger scheduled suite explores paraphrases, retrieval perturbations, multi-turn branches, and judge-assisted comparisons. Production sampling then tests whether those assumptions hold across unanticipated users, properties, traffic patterns, and integrations. This tier provides deterministic evidence on every change. Fast checks should be deterministic wherever possible. Pin the fixture inputs, retrieval snapshot, tools sandbox, expected state transitions, and scoring rules. A confirmation test can require that an ambiguous request causes no consequential lookup or recommendation. Ask for the missing property identifier, and that the resulting response conforms to the required output schema. These behavioral assertions are stronger than exact prose comparisons because wording can change while the contract remains intact. A pull request should run checks whose failures are interpretable and whose runtime fits the normal feedback loop. Suitable examples are fixture loading, schema validation, deterministic retrieval tests, policy boundary cases, and sandbox tool call assertions. Failures should identify the contract, fixture, and artifact versions involved. Live providers, uncontrolled web pages, and real calendars or databases are not suitable fast checks by default. Use recorded responses or sandbox fixtures instead, while covering the live dependency in a higher tier. A tightly controlled local service container or deterministic provider emulator can be used when its behavior and dependencies are pinned. In the assistant example, the prompt change fails the fast tier because the confirmation fixture records the state transition ambiguous request-clarification, while the candidate produces ambiguous request-property lookup. The changed artifact is the pull request report and its linked regression fixture, not the production dataset or an unexplained aggregate score. This tier contains scheduled, stochastic, and judge-assisted suites. Larger suites belong on a schedule or behind an explicit experiment trigger. They can use sampled paraphrases, multiple retrieval snapshots, randomized ordering, adversarial conversations, tool failures, and candidate versus baseline comparisons. Their variability helps discover brittle behavior, but makes them poor soul merge blockers. Record the seed when available, preserve the candidate configuration, and retain enough metadata to distinguish a code regression from ordinary evaluator variants. A judge can prioritize examples or compare responses with a rubric, but its rationale is evaluator-produced evidence, not proof of correctness or private reasoning. Inspect high-impact findings against the contract, source records, or human labels. For the real estate assistant, a nightly run can mix known confirmation cases with sampled paraphrases and retrieval perturbations. Expose a slice where direct question helpfulness improves, but confirmation on indirect follow-ups regresses. The scheduled artifact records the candidate and baseline, dataset and retriever versions, evaluator versions, slice outcomes, failures, cost or runtime budget, and links to reviewed examples. It supports investigating, promoting, or rejecting an experiment, but does not establish universal correctness. Tier 3 evaluates production, sampling, and drift. Production evaluation supplies distribution evidence that curated suites cannot. Sample traces according to a documented policy include ordinary traffic, stratify important workflows, and oversample permitted rare high-consequence events. Retain the trace identifier, model, or prompt version, retrieval metadata, tool outcome, latency, and user-visible result. Redact or exclude sensitive fields, apply access controls, and define retention according to privacy and domain requirements. Sampling must be observable, or a quiet failure mode may disappear because it was not selected. Monitor quality and operations across slices, such as ambiguous property references, long conversations, failed retrievals, tool timeouts, refusal boundaries, and new entry points. Drift may appear through a changing request mix, altered retrieval coverage, more clarification loops, or concentrated tool errors. When an alert appears, reproduce the pattern in a sandbox, review representative traces, and add a consented or safely synthetic fixture to the durable suite. An alert is not automatically a regression. This incident-to-regression cycle strengthens the lower tiers. A deterministic test can prove that the assistant asks for confirmation when a property identifier is absent, yet say nothing about a partner feed that introduces a malformed identifier. The fast tier can remain green while the integration is unsafe. Production evidence may reveal that malformed input slice, but it can be delayed or incomplete. Add a targeted sandbox contract and schedule an integration experiment rather than treating either tier as sufficient. The delivery artifact expresses how evaluation is allocated and where its limits remain. The companion workflow runs deterministic checks for pull requests and pushes, schedules the broader suite, and reserves production evaluation for a separately authorized job. It assumes shared schemas, fixtures, scorers, and sandbox components already exist without redefining them or requiring live credentials. Its explicit environment values are consumed by the shared evaluation harness. They make case count, trace volume, runtime, and cost ceilings, along with accountable owners, reviewable without embedding provider-specific behavior in the workflow. This workflow runs 3 evaluation tiers. Fast checks run on pull requests and pushes to main. Scheduled evaluation runs on the schedule or through manual dispatch. Production sampling runs only through manual dispatch with the production input enabled and the production evaluation environment. Each job checks out the repository, sets up Python, installs dependencies with hash verification, and runs its PyDis suite. Scheduled and production jobs upload their JUnit reports when those reports exist. Fast evaluation should produce either a passing PyDis result or a named assertion failure. Scheduled and production jobs produce JUnit reports for review. The shared configuration should validate case limits, runtime and cost ceilings, and owner metadata. The production policy should enforce trace volume, redaction, consent, and retention rules. Production sampling is manual and environment-gated because sampling real traces is governed. The upload condition preserves a report after failure when PyDis created it, while avoiding a misleading artifact when no report exists. Action references should be pinned, and the dependency lock file should be verified in a clean environment. These tiers can fail in known ways. Fixed fixtures can miss novel requests. Sampling can omit rare failures. Judge scores can reflect evaluator bias. Production traces can be incomplete or non-representative, and privacy constraints can limit what is retained. The evidence may support merging a change that passes the fast contracts, prioritizing an experiment, or pausing a canary after a sampled regression. It cannot prove universal correctness, safety across every slice, or that monitoring is unnecessary. The daily engineering artifact is the allocation of evidence across these layers. Fast contracts in CI, scheduled evaluation reports with lineage, and privacy-reviewed production sampling with an incident playbook. AI and product engineers maintain the contracts. Evaluation engineers maintain datasets and scores. Platform engineers maintain execution and lineage, and safety engineers examine consequential slices. A confirmation failure can thereby become a fixture, a scheduled check, and, when it appears in traffic, a monitored regression path. Design release gates. A prompt change can make an assistant warmer while causing a confirmation step to invoke the real send tool instead of the sandbox. That release must be blocked immediately. A small decline in tone quality should produce a warning rather than stop delivery. Treating both outcomes as the same failure makes the gate either unsafe or unusably sensitive. Start with the decision, not the score. A release gate is a decision policy over evidence. Its purpose is not to maximize an evaluation score. It asks whether the artifact may move to the next environment under specified safeguards. The strongest gates block only on signals that are reliable enough to trust and relevant enough to the decision. A small friendliness decline does not automatically decide a release because the score may be noisy, the test set may be small, and the change may not affect user-visible or consequential behavior. An unauthorized outbound message is different. It violates a deterministic contract, has explicit severity, and can be reproduced in the sandbox. That failure should block release even when aggregate quality metrics improve. A useful policy separates 4 outcomes: block, warn, pass, and insufficient evidence. Missing evidence must not silently become success. A repository may permit insufficient evidence in a low-risk development environment, but release and canary progression should require an explicit policy exception. Every outcome should name the evidence that caused it, the dataset or trace population examined, the comparison baseline, the warning budget window, and state, and the next action. A bare red or green status is not an investigation record. Hard gate intolerable failures. Hard gates belong around failures whose unacceptable nature does not depend on estimating a population rate. Calling a production tool from a test, omitting confirmation before a consequential action, leaking a protected field into an outbound payload, violating a schema contract, or producing an invalid tool authorization. Inspect the tool call trace. Compare the requested action with the approved sandbox contract, and assert that confirmation is present before execution. The real estate assistance confirmation fixture might request, send the inspection summary to Alex. The expected behavior is to draft the message, identify the recipient and attachment, and wait for explicit confirmation. A candidate that emits send_email before confirmation is blocked. The gate does not excuse that behavior because the wording improved, because the event was rare in a sample, or because a judge rated the conversation highly. A consequential action is a contract, not merely a preference. Hard gates still require careful scope. One fixture establishes that one known path is forbidden. It cannot establish that every possible tool path is safe. Include variants for missing confirmation, ambiguous confirmation, changed recipient, changed attachment, and retries. Keep the tool in a sandbox and record the attempted action without sending anything. Use warning budgets for noisy metrics. Tone ratings, retrieval relevance, groundedness judgments, resolution rates, and user feedback categories are estimates. They vary with sampling, evaluator behavior, and slice composition. A noisy metric should normally have a threshold and a warning budget rather than an unconditional block. For example, an assistant's historical tone score can decline from 4.20 to 4.05 on a fixed, representative comparison set and remain a warning when predefined policy treats that decline as a warning. Proceed to canary only when deployment policy permits it. Persist the metric scope, release, or time window identifier, maximum open warnings, current consumption, owner, and expiry. Atomically update accepted warnings. Repeated declines consume the budget and escalate to a block when the configured count is exhausted. Close expired warnings before evaluating a new warning and reject future dated state as invalid rather than treating it as available capacity. An LLM-Judge's rationale can help locate examples, but it is not proof of correctness or a substitute for an observable contract. Demand enough evidence and use paired comparisons. A gate should not react to a percentage calculated from too few cases. Set a minimum sample requirement for each noisy metric and return insufficient evidence when it is not met. This status should block release or canary progression unless environment policy explicitly permits continuation. It cannot support a claim that quality is unchanged. When the same cases can be run against both baseline and candidate, use a paired comparison. Pairing holds the request constant and makes the result about the change rather than different samples. Validate case IDs, input versions, tool state fixtures, evaluator versions, and candidate configuration. The declared sample count must equal the number of eligible paired cases. Each case ID must be unique. Every case must have exactly one baseline and one candidate result, and the corresponding identities must match. For multi-turn cases, preserve the complete conversation and state transition, not only the final answer. Reject a report that lacks this metadata or downgrade it to insufficient evidence. A candidate can pass 99 ordinary listing questions while failing the single fixture that changes a buyer's protected class preference into a recommendation criterion. Aggregate success cannot waive a domain-specific or policy-specific contract. Real estate examples require domain review. A statistical result does not establish legal compliance. Every block needs an investigation path. A blocked release should answer 4 questions. Which rule fired? On which cases or traces? Against which baseline? And what evidence can clear the block? Attach the smallest reproducible artifact. Input, conversation state, tool trace, expected contract, actual event, score versions, and environment identifiers. Classify the failure as a contract violation, dataset issue, evaluator issue, product policy change, or genuine model regression. The gate artifact is a report rather than only a CI exit code. It records hard failures, warning budget configuration and consumption, warning expiry, release and window identity, sample sufficiency, paired comparison metadata, and representative evidence. Unauthorized sending blocks the merge, while the tone warning enters the canary investigation queue only when policy permits. A confirmed traffic incident can become a minimized regression fixture, with the relevant gate strengthened. This provider-neutral policy consumes an explicit budget state object and returns updated state. The repository adapter imports shared schemas and the fixture from the cumulative evaluation package. It does not redefine those shared elements, call a model, or call a real tool. The code evaluates an experiment report against a gate policy and returns an outcome, reasons, and updated warning budgets. It first blocks on any hard failure. Otherwise, it validates paired comparisons using declared sample counts, minimum samples, present baseline and candidate sides, unique case IDs, and matching input versions, fixture IDs, and evaluator IDs. A metric decline beyond its allowance creates a warning. Each warning consumes its configured budget. A missing or exhausted budget blocks, while valid warnings return warn with updated state. Insufficient evidence returns insufficient_evidence, but blocks outside development unless development allowance is explicitly configured. The example report contains a confirmation contract hard failure, so the assertion expect block and the final print emits the outcome and reasons. The explicit fixture import is the repository adapter boundary. Its shared fixture must contain the paired baseline and candidate records used by 11.2. The assertion verifies that the deterministic violation dominates the tone warning. With that hard failure removed, a valid 40 case, paired comparison returns warn and updated_budgets records one consumed slot. Reusing the return state causes a later warning to exhaust the configured budget and return block. An expired state is normalized to 0 open warnings for the same documented window. A future or otherwise invalid expiration raises an error. Mismatched declared and paired sample counts, duplicate IDs, missing sides, or mismatched versions return insufficient_evidence and block release by default. Persist the updated budgets atomically with the gate report using the authenticated artifact store and the release or window identifier. Automated tests should cover pass, warn, block, repeated consumption, exhausted and expired budgets, invalid pairings, hard failure precedents, and insufficient evidence. Run them in a clean environment with the repository lock file before publication. Consequential tools remain sandboxed. The gate supports scope decisions within its evidence boundaries. This evidence can support a scope decision to block a release, permit a canary with a documented warning when configured policy allows it, or request more data. It cannot prove universal correctness, establish legal compliance, detect failures absent from the sample population, or show that a judge's explanation is true. Sampling bias, incomplete traces, evaluator drift, fixture leakage, and untested tool paths can defeat the policy. The release gate is reliable only within its contracts and evidence boundaries. That boundary is part of daily engineering work. AI and product engineers maintain behavioral contracts. Evaluation engineers maintain paired datasets and scores. Platform engineers preserve lineage, budget state, and reproducibility. Safety engineers review consequential slices and har blocks. The next operational step is to deploy the decision through a controlled canary, monitor quality and tool behavior, and convert a confirmed incident into a regression test rather than merely closing a ticket. Run evaluations in CI before merging changes. A one-line prompt change can improve the real estate assistant's demo while silently breaking confirmation behavior. If the assistant sounds more decisive but skips the required confirmation before creating a showing request, a green manual review is not evidence of safety. Run the smoke suite in GitHub Actions before merging. Preserve the exact inputs and outputs, and make the release decision from an artifact someone else can inspect. Reproducible lineage makes CI evaluation runs meaningfully comparable. A CI evaluation is an experiment only when another run can be meaningfully compared with it. Preserve the commit SHA, evaluator version, fixture set version, system and prompt fingerprints, model identifier as returned by the provider, configuration flags, dependency lock file, random seeds where applicable, and the timestamp and execution environment. A report that says 18 of 20 passed without this lineage is a result without a stable interpretation. Pin the application and evaluator dependencies in the repository's lock file, verify the lock file in CI, and record the runtime version and operating system image. Fingerprint the system prompt, tool schemas, policy configuration, and scoring rubric, preferably with content hashes rather than copying sensitive content into logs. Provider-specific adapters should remain behind the shared interface established earlier. Their changing behavior belongs in the run metadata, not in an unrecorded assumption. The smoke command should use the repository's shared schemas, fixtures, scorers, and sandbox components. It should write a machine-readable result containing case IDs, outcome, evaluator version, latency, and cost fields when available, and failure references. A human-readable summary is useful, but it is not a substitute for the structured artifact. Make CI fast through safe caching, without weakening the evidence. Cache only deterministic, non-sensitive intermediates. Dependency wheels, a lock file keyed package cache, and immutable fixture transformations are usually safer candidates than model responses. Never cache outputs that contain user data, credentials, authorization headers, tool results with private records, or state whose validity depends on the current branch or environment. Include the relevant commit, fixture, prompt, and evaluator fingerprints in cache keys. Otherwise, a stale pass can survive a meaningful change. Concurrency needs an explicit budget. A matrix that launches every evaluator against every case can exhaust provider quotas, create non-deterministic throttling failures, or overwhelm a sandbox. Limit workers, set bounded retries with backoff, and distinguish a rate limit or infrastructure error from a behavioral failure. Do not retry a consequential tool call merely because the network failed unless the sandbox contract makes that retry safe and idempotent. For pull requests, a small deterministic smoke set can block. Broader suites can run on protected branches or on a scheduled basis. The workflow below assumes the companion repository already supplies evals/smoke.py, shared fixtures, and a sandbox that prevents email, calendar, browser, and database side effects. The command writes artifacts/smokereport.json. The workflow uploads that report and any failed traces even when assertions fail. The workflow runs the smoke evaluation on pull requests and pushes to main. It bounds concurrency with two workers, cancels an in-progress run for the same group, pins the Python version through .python version, installs hash-checked lock dependencies, runs the sandbox smoke suite with shared fixtures, and uploads the report and failed traces regardless of the assertion result. The workflow pins the interpreter through .python version and dependencies through a hash-checked lock file. The action references above are readable version references for the example, but the companion repository must replace them with the exact commit SHAs approved by its supply chain policy, record those SHAs in its verification notes, and rerun the workflow after the change. The runner image must likewise be checked against the repository's supported image policy. Do not treat a mutable action tag or an unverified runner image as a reproducibility guarantee. Verification for the companion repository consists of a clean checkout, installation from the exact lock file, and a pull request run using the repository's configured Python version. Confirm that Evals, the smoke imports the shared schemas, fixtures, scorers, and sandbox, creates the report and failed trace directories, records the commit and system fingerprints, and exits non-zero for a behavioral failure. Force one fixture failure and confirm that actions/upload artifacts still publishes both artifacts/smoke report.json and any files under artifacts/failed traces because the upload step has if always. The expected successful output is a report with the commit and system fingerprints, all required smoke cases evaluated, and an overall passing assertion. A forced behavioral failure should produce the same report and trace artifacts while causing the job to fail. These checks are repository verification requirements, not claims that the illustrative workflow has been executed in this text. Sandbox is a safety boundary, not decoration. The smoke suite must fail closed if the sandbox is unavailable, rather than silently exercising live tools. The artifact then tells the reviewer whether the prompt change caused a confirmation regression, which case exposed it, and which contract was violated. Return to the confirmation regression. In case showing 014, the user supplies a property and preferred time and asks the assistant to schedule a viewing. The assistant may draft the request, but explicit confirmation is required before the sandbox calendar tool is invoked. Before confirmation, it makes no calendar call. After confirmation, it makes exactly one permitted calendar call. The smoke fixture should assert both the conversational response and the tool trace. A prompt revision can fail on the tool trace, even when its language quality score is favorable. If a user confirms one property and then changes the date or property in the next message, the earlier confirmation does not authorize the changed action. This belongs in the smoke suite because confirmation depends on state, not phrase matching. A smoke pass still supports only the scope decision covered by its fixtures and evaluators, not every multi-turn authorization path. From CI evidence to operational practice. The artifact changes at this stage. The release decision from the previous section is now accompanied by a reproducible run bundle, report, failed traces, fingerprints, and dependency identity. AI engineers maintain the behavioral contracts and fixtures. Evaluation engineers maintain score versions and failure taxonomies. ML platform engineers maintain runners, artifact retention, concurrency controls, and secret boundaries. Product and safety engineers decide which failures are blocking. This is daily delivery infrastructure, not a one-time test script. The evidence can support merging, blocking, or routing a change to a canary when the suite scope and reliability justify that policy. It cannot prove universal correctness, detect failures outside the fixtures, establish that an evaluator rationale is true, or distinguish all provider-side changes from application changes. Failures can also arise from quota exhaustion, sandbox defects, fixture leakage, evaluator drift, or an incomplete system fingerprint. Treat infrastructure failures as evidence gaps rather than behavioral passes, and record the decision to rerun or investigate. A practical completion loop is run the smoke suite in CI, inspect the uploaded trace, fix or reject the change, deploy an approved version to a small canary, monitor quality and operational signals, and turn any confirmed incident into a minimized regression fixture. The next run should demonstrate that the incident remains covered. Evidence becomes durable when the failed behavior, its expected contract, and the environment that exposed it travel together. Observability for AI workflows. A one-line prompt change makes the real estate assistant sound more helpful in the demo and silently stops it from asking for confirmation before booking. Without production-like traces, the team sees only a successful HTTP response. With traces, it can see the search results, the missing confirmation state, the booking tool call, the evaluator score, the latency, and the release that introduced the behavior. Evidence must travel with the workflow. Instrument the assistant as a workflow rather than as one model call. A useful trace follows a single user task through meaningful steps, such as searching for a property, refining the search, selecting a listing, and requesting a booking. The assistant.request span is the root. It identifies the request, session, tenant, release, experiment, traffic class, and run. The search.retrieve span captures normalized filters, the retrieval count, result identifiers, the schema version, and retrieval latency. The assistant.generate span records which model adapter ran, which prompt template version it used, available token counts, and a response classification. The booking.confirmation span shows whether confirmation was required, observed, and accepted, together with the resulting workflow state. The tool.booking_sandbox span records the sandbox tool name, argument schema version, authorization decision, outcome, and execution duration. The evaluation.online span records evaluator outcomes after sensitive values have been removed or replaced. The trace joins 5 evidence categories: behavioral quality, operational performance, economic consumption, workflow state, and identity. Quality can include contract checks, such as booking.confirmation_required, booking.confirmation_observed, and evaluation.contract_pass. Latency covers each span and the end-to-end duration. Cost records measured usage or a deliberately labeled estimate. State records the assistant transition and tool authorization. Identity covers release, experiment, evaluator, fixture, and dependency fingerprints. The companion repository uses one canonical observability event schema. Every producer maps its data to the same bounded field names and types, keeping later sampling, SLO, canary, drift, and readiness artifacts comparable. The schema connects workflow and operation linkage, immutable release and environment context, experiment assignment and traffic segmentation, replay and session correlation, workflow identity and state, evaluator identity, retrieval evidence, usage and cost, and operational or side effect evidence. Downstream artifacts use these canonical fields for sampling, canaries, drift, quality, SLOs, incidents, readiness, regression, and cost analysis. The schema has its own version separate from application releases. Compatibility testing rejects events when a required field changes type. An enum is renamed without migration, or an attribute uses a non-canonical alias. Downstream reports consume the mapping instead of scraping arbitrary span names, preventing a renamed field, such as confirmation_observed, from silently appearing as a quality improvement. A trace should identify what happened, the release under which it happened, the inputs and tools involved, and the evaluator used. It should not become an unbounded dump of prompts, customer records, or hidden provider internals. Stable identities and span attributes provide the context needed for comparable observability evidence. Release and experiment identifiers belong on the root span, so child operations inherit the context when context is active. Record an immutable application release identifier, deployment environment, fixture or traffic class, experiment assignment, and run identifier. For replays, keep the replay or run identifier separate from the original identity. Across tasks, queues, or process boundaries, Propagate trace context explicitly and test that the child span remains linked to the originating workflow, because inheritance is not automatic there. Evaluator identity is essential for comparison. A score of 0.82 is not comparable evidence without the evaluator, rubric, or policy, and dataset or sampling policy versions, because those may have changed. An LLM-Judge's rationale can help triage a failure, but it is evaluator output rather than proof that the response was correct. Keep attribute names bounded and searchable. Use attributes for identifiers, classifications, booleans, counts, and durations, and place large payloads in controlled artifacts referenced by an identifier. Never use raw user text, listing descriptions, email addresses, phone numbers, or booking notes as metric labels, because high cardinality and sensitive values make retention, access control, and incident review harder. The run bundle adds the canonical observability schema, its field mapping table, compatibility tests, and a trace fixture for one search and booking session in the existing sandbox. The schema makes release, state, evaluator, and tool evidence queryable, so a CI or canary report can link a failing contract to the exact workflow path rather than merely to an endpoint. Instrumentation includes redaction. Redact before export, not after traces reach a shared dashboard. Allow list the fields that may leave the application boundary, and replace direct identifiers with scoped, non-reversible references where correlation is necessary. Remove freeform booking notes unless a review process explicitly permits them. Separate access to raw event artifact from aggregate metrics. Make trace access auditable, and use synthetic or consented data for production-like sessions, especially when they include addresses, household information, or communications. Tool spans require an additional boundary. Record the sandbox, tool name, validated argument shape, authorization decision, and result class. Do not record credentials, unrestricted tool payloads, or copied customer records. A trace that exposes a booking token is a security incident, not successful observability. Here is a small Python adapter that emits OpenTelemetry-compatible spans while using the shared assistant sandbox, canonical observability schema, fixture, and scorer. The repository's stable import paths are used as the integration boundary rather than redefining competing toy fixtures. Its in-memory exporter means the example has no network destination or real credentials. The adapter instruments one search and booking session and returns the number of finished spans. It creates an in-memory telemetry provider, emits scalar allow-listed attributes, records a root request span with release, deployment, experiment, traffic, run, state, and workflow evidence, and then records retrieval, generation, confirmation, sandbox tool, and online evaluation spans. The shared fixture supplies the existing search results, state contract, prompt template version, booking schema, and run identifier. The shared scorer supplies the version contract result. The in-memory booking sandbox validates the booking request without sending email, changing a calendar, or creating a real reservation. The expected output is exported underscore spans equals 6, one root span plus retrieval, generation, confirmation, sandbox tool, and online evaluation spans. One synthetic session therefore produced a complete evidence trace, and the booking action was blocked because confirmation was absent. The companion repository must run its checks against the canonical schema and pinned dependency lock file. Validate every emitted event against the canonical field mapping. Preserve required field types and enum values, and redact synthetic secrets, direct identifiers, free-form notes, credentials, and unrestricted tool payloads from exported spans. Preserve originating trace relationships across asynchronous, queued, and remote boundaries. A failed or back-pressured exporter must not authorize a booking or change workflow behavior. Repeated initialization must not replace the process global provider or duplicate processors. The same trace fixture must be accepted by sampling, SLO, canary, drift, and readiness readers. A production implementation must configure exporters, bounded payload handling, sampling rules, back-pressure behavior, shutdown flush, automated tests, and pin dependencies. Verify current OpenTelemetry semantic convention names rather than assuming illustrative application attributes are canonical. Keep provider-specific adapters outside the durable core example. A missing span can indicate sampling, exporter failure, context propagation loss, or an uninstrumented code path. It is not evidence that the operation did not occur. A passing evaluator can reflect an incomplete contract or an unrepresentative trace, and latency and cost fields may be unavailable or estimates, particularly across provider boundaries. This evidence supports a canary decision, incident diagnosis, and targeted regression creation, but it cannot establish universal correctness, prove causation from correlation alone, or justify exposing sensitive traces broadly. Deploy the prompt change to a small canary. Sample search and booking traces. Compare contract outcomes and operational signals by release and variant, and block or roll back when the confirmation contract fails. When an incident is confirmed, preserve the failing state transition, add its trace fixture to the regression dataset, and record the evaluator version that detects it. AI engineers maintain the contract and fixture. Evaluation engineers maintain the scorer and taxonomy. Platform engineers maintain context propagation, retention, and access controls. Product and safety engineers set the release threshold. This division of work makes observability an engineering artifact rather than dashboard decoration. Traces make behavior inspectable. Canonical identifiers make it comparable across later systems, and preserved fixtures make the lesson repeatable. A defined event contract and a safe place to attach online evaluation allow the following section to sample real traffic without evaluating every request. Capture trace, quality, latency, cost, and state evidence together. Attach release, experiment, and evaluator identities. Use one version field mapping across downstream artifacts. Redact before export. Test propagation, failure, initialization, and compatibility. Use the shared sandbox and schemas, and turn confirmed production failures into version regression fixtures. Next, examine how online evaluation can be allocated selectively across different session types. A search-only session may be sampled at 1%, a booking session at 25%, and an email sending session at 100%. Evaluating every trace is expensive, while treating every trace equally can make a rare, consequential failure invisible. The real estate assistant can monitor broad trends while giving scarce evaluation and human review capacity to state-changing behavior. Sample for the decision you need to make. Online evaluation does not require scoring every request. It needs enough evidence to detect material changes in important behaviors within the production system's latency and cost budget. First, state the target estimate. Here, the pass rate among all eligible production traces in a defined monitoring window, with each trace contributing according to its observed outcome. Other targets require different populations and estimators, such as booking only, newly released, or severe failure rates. Trace contracts contain release identifiers, workflow state, tool events, quality signals, and redacted payloads. Sampling adds a selection decision to that contract and preserves the information needed to interpret the resulting measurements. For trend measurement, begin with random sampling within a defined population. When every eligible search-only trace has the same known selection probability, the observed pass rate is usually a direct estimate of that population's pass rate, subject to ordinary sampling error and score quality. Convenience samples, such as unusually long responses or traces already noticed by an operator, can distort trends before inspection. Use stratification when risk or product change justifies it. The assistant's initial partition distinguishes search-only, booking, email, and new feature or release paths. Apply different policies by stratum. Search-only retrieval and answers can use a low random rate for broad trend coverage. Booking receives a higher rate because state changes are consequential. Email receives the highest rate or mandatory evaluation before the side effect. Newly deployed confirmation or tool logic is temporarily oversampled until evidence accumulates. Sampling rates are policy choices, not universal defaults. Record each rate with a trace, along with the eligible population definition, stratum definition, policy version, and monitoring window boundaries. A booking trace sampled at 25% is not interchangeable with a search trace sampled at 1%, even when both receive the same evaluator. Correct unequal sampling rather than hiding it. If some trace types are selected more often, their raw pass rate describes the sample rather than all production traffic. To estimate the overall rate, retain each eligible trace's inclusion probability. The probability it would have been selected under the policy, conditional on the log population and stratum. This probability must be positive for every relevant population unit, known or accurately logged before outcome-based selection, and aligned with the denominator being estimated. Let you be the eligible production population in a specified monitoring window. For trace I, Y is 1 for a pass and 0 for a failure. Pi is its known inclusion probability, and I indicates whether it was sampled. The target is the finite population pass rate P, the average of Y across U. The inverse probability-weighted ratio estimate uses these quantities. The numerator expands sampled successes to represent the population. The denominator expands the sampled population itself. This ratio form is practical when the exact population total is unavailable. It assumes that eligibility is defined independently of the outcome. Inclusion probabilities are known or accurately logged. Selection is random within the stated strata. Sampled outcomes use one consistent definition, and the observed sample covers every stratum in the target population. A very small probability can create a large weight and a noisy estimate, so minimum sample counts, uncertainty intervals, and sensitivity checks still matter. Weighting cannot repair an omitted stratum, zero inclusion probability, corrupted trace contract, biased evaluator, or a policy that silently excludes failures. The estimate alone does not provide a confidence interval for a formal confidence or release decision. The monitoring system must also retain the population counts and stratum structure and use an uncertainty method appropriate to the sampling design. For example, design-based variance estimate or a pre-specified resampling procedure. If those inputs are unavailable, report the weighted point estimate as descriptive evidence, not as a precise population claim. Escalation rules for severe failures should not wait for statistical certainty. A single credible state-changing failure can require human review or a release hold even when the aggregate estimate is favorable. For example, suppose the assistant has 1,000 search traces, 100 booking traces, and 20 email traces in one defined monitoring window. The monitoring policy samples 1%, 25%, and 100%, respectively. In a particular batch, the sample contains 10 search traces with 8 passes, 25 booking traces with 20 passes, and 20 email traces with 18 passes. The raw sampled pass rate is $46.55, or about 84%. It overrepresents email and booking behavior. Applying weights of $1/0.01 equals $100, $1/0.25 equals $4, and $1/1 equals $1 gives. Backslash hat Peak gleich Backslash Frag 8 100 plus 20 4 plus 18 1 10 100 plus 25 4 plus 20 1 gleich Backslash Frag 898 1120 Backslash approx 0.802. The weighted estimate is about 80%, not 84%. It estimates the pass rate for the stated 1,120 trace-eligible population, assuming the displayed sample counts arose from a stated random policy and the outcomes are comparable. It supports a trend comparison against similarly defined, similarly weighted batches. Without design-appropriate uncertainty calculations, it does not support a claim that the difference is statistically meaningful. It also does not by itself authorize a release. The email subgroup has 18 passes out of 20, and a single severe failure could still require blocking despite a favorable aggregate rate. Route risk and uncertainty deliberately. Random sampling supplies trend evidence. It is not a substitute for risk controls. The assistant should oversample new confirmation behavior, unusual tool sequences, policy-sensitive requests, and traces involving booking or email side effects. A new release can receive a temporary elevated rate, with the policy carrying an expiration or review condition so that an emergency oversampling rule does not become an unexplained permanent cost increase. The evaluator should also emit an uncertainty or escalation signal. Route cases to human review when the score is near its decision boundary, when required evidence is missing, when a tool action conflicts with the declared workflow state, or when the consequence is severe even if the automated score appears favorable. Human review should inspect the redacted trace and recorded state transition, not an alleged private rationale from model judge. Review outcomes need stable labels, reviewer guidance, and an audit trail so that disagreement becomes data rather than an untracked override. Consider one boundary case. A search-only conversation asks whether a listing is available, but the assistant accidentally invokes the booking tool. Its nominal stratum is search-only, yet its observed action is risky. A policy that samples only by the user's initial intent can miss this case. The sampler therefore needs both declared workflow metadata and observed tool events, with an escalation rule that promotes unexpected side effects into the higher-risk queue. If promotion occurs after selection, the promoted queue is an escalation mechanism, not evidence that can be treated as a simple random sample of the original population. Its altered selection process must be recorded before interpreting its rates. For the cumulative assistant, the artifact that changes is the online sampling policy and its trace schema. Each sampled record should include the policy version, target population and monitoring window, stratum, inclusion probability, random selection result, evaluator version, escalation reason, and eventual human disposition. The sampled fixture then feeds the same regression dataset used in CI. An incident is closed only when its preserved state transition reproduces the failure. The evaluator detects it, and the sampling policy would make comparable future traces visible. A durable sampler with safe defaults. The following standard library implementation is deliberately provider-neutral. It imports the repository's shared trace contract rather than defining a second, incompatible trace object. In the companion repository, Chapter 11.shared trace_schema. Trace is the adapter established by the preceding observability section. It exposes the existing trace_ID and stratum fields while retaining release, workflow state, tool event, quality, and redaction metadata. The sampler only reads those two routing fields and therefore does not discard the rest of the shared contract. It also includes the weighted estimator used by the monitoring report, with tests for unequal sampling probabilities and the numerical example above. The implementation is provider-neutral. It uses the shared trace contract, samples records by configured stratum rates, and retains each selected record's inclusion probability. Risk-stratified sampler rejects empty rates, rates outside 0, 1 and traces from unconfigured strata. Its seeded random generator selects records and stores their probabilities. Weighted underscore rate validates binary outcomes and valid inclusion probabilities, applies inverse probability weights, and returns the weighted numerator divided by the weighted denominator. The main block constructs search, booking, and email traces, samples them with configured rates, checks the selected records and probabilities, verifies the weighted estimate, and prints the selected records and estimate. With random, 7. The first three values are approximately 0.3238, 0.1508, and 0.6509. Search is not selected because 0.3238 is greater than 0.01. Booking is selected because 0.1508 is less than 0.25, and email is selected because every email trace is included. The expected output records the selected trace IDs with their inclusion probabilities, followed by the weighted pass rate. The first assertion verifies deterministic risk-stratified selection. The second verifies that each selected record carries the probability required for weighted analysis. The estimator test expands the numerical example into binary outcomes and checks $898/$1120. Production tests should cover unknown strata, invalid rates, deterministic replay, empty input, policy version serialization, shared trace metadata, and the exact target population denominator. Add design-appropriate variance or interval calculations before presenting weighted estimates as confidence-bounded release evidence. Use mocks or sandboxes for consequential tools. The sampler does not enforce consent, retention, redaction, rate limits, or human escalation. Those controls belong around it. What the evidence can support. This design supports release-to-release trend detection, targeted monitoring of risky workflows, prioritization of human review, and a defensible path from incident to regression fixture. It can support a canary decision when the target population, sample counts, weighted quality, design-appropriate uncertainty, operational signals, and severity rules are reviewed together. It cannot establish universal correctness from a sample, prove that a release caused a change without a suitable comparison, or guarantee detection of a rare failure whose inclusion probability is effectively zero. A weighted point estimate without appropriate variance information cannot support a precise confidence claim. Drift in user mix, missing traces, evaluator changes, and systematic refusal to log failed tool calls can invalidate the estimate. AI engineers maintain the workflow contract and fixtures. Evaluation engineers maintain scores, target estimates, and weighting. Platform engineers maintain sampling, retention, and access controls. Product and safety engineers define severity and escalation thresholds. Evaluate enough real traffic to see meaningful change. Sample randomly for trends. Oversample risk for discovery. Log inclusion probabilities and denominators for interpretation, and send uncertain or severe cases to people. Deploy through a canary. Monitor weighted quality alongside latency, cost, and completion signals, and turn each confirmed incident into the next version regression test. Operational SLOs. Before changing the prompt, define SLOs for listing search and showing booking. Without them, a revision that sounds better in a demo could increase confirmation errors, exhaust latency budgets, or raise the cost of successful tasks. Operational measurement must focus on whether the user completes the task, rather than treating answer quality as the complete objective. An evaluation score is not an operational objective by itself. The assistant must help the user find listings that satisfy the request and show booking information without inventing availability or implying that a reservation was made. Quality, therefore, sits alongside latency, availability, cost, and completion. A listing search task succeeds when the assistant preserves the user's hard constraints, returns listings supported by the sandbox data contract, discloses when no result satisfies every constraint, and avoids disallowed inferences about protected characteristics. Fluent prose does not make a response partially successful if it violates a hard constraint. For showing booking, the assistant must identify the selected listing, retrieve details through the approved sandbox interface, distinguish availability from a completed booking, and present dates, price, and relevant conditions without fabricating confirmation. Record the task outcome separately from component scores, such as retrieval relevance or response quality. An SLO states its target over a defined window and population. For example, at least 99% of eligible listing search tasks might meet the task success definition over a rolling production window, while booking information tasks might have a stricter intolerable error rule. These thresholds are product decisions, not universal constants, and must be agreed with the owners of the workflow, its risks, and its service budget. Success rates alone are not enough. Operational SLOs must also account for events that are unacceptable even when rare. Aggregate success can conceal failures that are unacceptable even when rare. Add intolerable event counters alongside success rates. For this assistant, define useful intolerable event counters. Count a booking confirmation as a critical event when it is claimed without a successful sandbox booking response. Count prices, dates, availability values, or listing identifiers that are fabricated or contradicted by the source record. Count cases where a hard user constraint is silently dropped during search. Count consequential tool calls made outside the approved sandbox or without the required authorization state. Count responses that expose more personal or transactional data than the task requires. These counters need explicit denominators, severity labels, and ownership. One confirmed fabricated booking confirmation may trigger investigation or rollback, even when the weekly success percentage remains above target. Do not increment a counter merely because an evaluator is uncertain. Record that uncertainty in review queues and confidence metadata instead of treating it as an invented fact. Assess responsiveness at the slow end, alongside whether the task was completed. Average latency is a poor description of an interactive system. Track at least the high percentiles for end-to-end latency and, where useful, separate retrieval, model generation, evaluator or policy checks, and tool calls. Tail latency can reflect retries, queuing, slow dependencies, or unusually long conversations, which can cause users to abandon a task. Cost should likewise be reported per successful task, not only per request or token. A cheaper request that fails and causes a retry, human escalation, or abandoned search may be more expensive at the workflow level. Attribute model, retrieval, tool, and review costs consistently. If some costs are unavailable, label the metric as partial rather than presenting it as total cost. The resulting operational review might compare 4 linked questions. How often did the task succeed? How often did an intolerable event occur? How long did completed and failed tasks take at the tail? What did each successful task consume? These views prevent a quality gain on a small, easy subset from masking degradation in difficult or high-value workflows. The listing search and booking thread. Suppose a prompt change improves constraint preservation scores in offline tests, but adds a verification step before showing booking details. Listing search may improve while booking latency rises and completion falls for users who abandon the page. The correct response is not to optimize the quality score independently. Inspect the joint evidence. Eligible task counts, successful task counts, P95 or P99 latency, availability, cost per successful task, and each intolerable event counter. The section artifact is a versioned SLO manifest. It binds task definitions, windows, metric names, thresholds, severity, and alert behavior to the assistant's existing schemas and sandbox fixtures. The trace sampler from the previous section supplies eligible observations and inclusion metadata. This manifest states how those observations are judged operationally, rather than replacing the sampler. This version SLO manifest defines the service, observation window, task eligibility and success criteria, intolerable event limits, operational metrics, cost comparison rules, and alert behavior. The complete manifest is: the manifest expressions are contracts for the repository's existing trace query layer, not a new evaluator or provider-specific API. They make rates reproducible. Unsupported transaction details use eligible showing booking tasks over a rolling 24-hour window. Availability uses healthy requests divided by all requests over the same window, and cost compares the rolling day with the preceding 7-day, same weekday, baseline only when at least 100 successful tasks exist. Missing cost components mark the metric partial and prevent comparison. Availability below its alert threshold pages the on-call owner. Fewer than 1,000 requests marks the result unknown and pages rather than declaring success. A small repository-compatible validation artifact can exercise this contract without credentials or external side effects. Save the manifest as artifacts/operational_slows.yaml. Pin PYAML equals 6.0.2 in the companion lock file, and add the test as test/test_operational_slows.py. This test loads and validates the operational SLO manifest without external side effects. It requires production as the declared environment, sandbox-only consequential tools, the two named tasks, required task and operation fields, ordered SLO thresholds, metric structure, intolerable event bounds, and cost comparison fields. It returns exactly valid, true, checks, 7, external_effects, 0, and the test asserts that exact result. The 7 top-level contracts are 2 task SLOs, 2 intolerable event definitions, and 3 operational metrics. The existing trace query layer calculates production rates. A passing PyTest result means the configuration is structurally valid and side effect free. Not that production currently meets an SLO. Production evaluation must also handle low volume, late traces, duplicate events, evaluator version changes, and partial outages rather than treating missing data as success. These boundaries define what the SLO evidence can and cannot support. These SLOs support release decisions about observed task performance under specified traffic and measurement contracts. They do not prove universal correctness, establish causal attribution without a suitable comparison, or reveal failures absent from sampled traces. Thresholds can be gamed by changing eligibility, and broad success predicates can hide severe subcases. Rare harms may remain invisible until a targeted test, report, or human review finds them. Real estate examples also require privacy and fair housing domain review. An operational target is not a policy determination. AI engineers define workflow contracts and regression fixtures. Evaluation engineers maintain scores and denominators. ML platform engineers maintain trace integrity and alert delivery. Product engineers connect completion to user flows. Safety engineers define intolerable events and escalation. The shared artifact makes these responsibilities executable and reviewable instead of leaving them as a dashboard convention. For listing search and showing booking, do not deploy a quality improvement on quality evidence alone. Require acceptable task success, 0 or bounded intolerable events, viable tail latency and availability, and a defensible cost per successful task. Carry the manifest into the canary, investigate any breach, and turn a confirmed incident into a version regression case before the next release. The next boundary concerns exposing changes to production traffic, comparing them with a control, and preserving immediate recovery. Canary a new re-ranker for 5% of eligible search traffic, and remember that a prompt change that improves a demo can silently break the assistant's canonical confirmation contract for real users. Do not promote an apparent quality improvement because an offline score rose. Expose it first to a small, eligible slice of production traffic. Compare it with a contemporaneous control, and keep the previous configuration immediately recoverable. A canary treats production exposure as an experiment bounded by safety boundary. A canary answers a narrower question than whether the whole new system is better. Under a defined routing rule, did the candidate improve the intended task for eligible traffic without violating the confirmation contract or causing unacceptable operational degradation? For the real estate assistant, the candidate is a new re-ranker that has passed the preceding offline evaluation gate. It changes only the ranking stage. The same listing identifiers, policy-filtered candidate set, provenance fields, and sandbox booking tools continue through the system. The confirmation contract also remains unchanged. The assistant makes the selected listing and intended booking action clear, then obtains explicit confirmation before invoking the booking tool. Success is completion of the eligible search to confirmation task. The user receives a qualifying, provenance-supported result and reaches valid explicit confirmation without an invalid listing, premature tool invocation, or confirmation failure. If retrieval, prompt construction, and booking logic also change, the canary can detect a problem but cannot identify which change caused it. Start with small traffic. A 5% routing allocation is not evidence of statistical sufficiency. Define eligibility before exposure. Then preserve assignment and record exposure evidence. Eligible traffic has supported production searches, policy-filtered inventory, required provenance, and the fields needed to evaluate confirmation. Exclude internal traffic, synthetic probes, known load tests, and requests missing those fields. Decide whether repeated sessions belong to the same assignment. Then preserve that assignment, so users do not alternate between control and candidate mid-task. Record the configuration version, cohort rule, exposure timestamp, request identifier, session identifier, and exclusion reason. Do not define eligibility after observing outcomes. Keep the prior re-ranker live for the eligible cohort's remaining traffic and preserve the same retrieval, confirmation, and tool contracts. Because different geographies, property types, device mixes, or time periods can mislead raw averages, stratify summaries by dimensions that plausibly affect search and confirmation, including query type, inventory availability, user journey stage, and region where appropriate. Pairing related requests may improve sensitivity, but it does not remove interference or guarantee causal interpretation. Do not let the primary task metric hide secondary quality failures or operational degradation. The primary outcome is successful completion of the canonical search to confirmation task. Secondary measures include ranking relevance, qualifying listing selection, provenance completeness, and targeted human or evaluator judgments. Guardrails include invalid listing identifiers, missing provenance, policy filter violations, unsafe or misleading claims, confirmation contract violations, showing booking failures, abandonment, latency, availability, tool errors, and cost per successful task. Better click-through or offline relevance cannot compensate for a new confirmation failure or prohibited recommendation pattern. Use aggregate and slice-level views because a candidate can improve broad search while degrading an important class, such as no-result queries, ambiguous addresses, or listings with incomplete metadata. Human review and targeted evaluators remain necessary for failures that automated success signals cannot reliably observe. Preserve the underlying trace. Treat an LLM-Judge's rationale as an evaluation record, not proof of correctness or private reasoning, and label the judgment as an instrument with known limitations. For the 5% re-ranker canary, Retain every candidate exposure involving a high-severity event and a reproducible sample of ordinary traffic. Record sampling rates with each trace so denominators remain interpretable. Minimize or redact personal data, and use synthetic or sandboxed booking events for development and testing. Real estate traces require review for privacy, consent, and fair housing implications. Observing a metric does not validate the underlying policy judgment. Rollback is a pre-committed action, not a dashboard reaction. Define rollback criteria before exposure. The primary rollback breach is a material regression in completion of the canonical confirmation task, especially any sustained increase in confirmation contract violations or premature booking tool invocation. Other breaches include any intolerable policy or security event, a sustained breach of a latency or availability objective, a material increase in booking tool failures, or a quality regression in a protected slice. These are release breaches, not metrics to average away. Secondary relevance or click-through changes can inform diagnosis and promotion, but they do not override a confirmation breach. Sustained must be operationally defined in the release manifest. A window, minimum eligible volume, alert condition, owner, and escalation path. Avoid thresholds that can be satisfied by losing data. Missing evaluations should be visible as missing, never counted as success. Preserve the prior configuration as an immutable, addressable release. A rollback should change routing to the known good version without rebuilding artifacts under pressure. Store the candidate's evaluator version, feature flags, ranking model identifier, prompt or policy bundle, confirmation contract version, and data contract alongside the decision. Test rollback in a sandbox before production exposure, and verify that in-flight sessions, caches, and asynchronous jobs do not continue using the candidate unexpectedly. The re-ranker canary therefore has a concrete release rule. After the offline gate, route 5% of eligible search sessions to the candidate. Retain 95% on the contemporaneous control. Compare the primary search to confirmation outcome by stratum and monitor secondary quality and operational guardrails. Stop or revert on a pre-declared confirmation contract breach or other protected guardrail breach. If the candidate improves ranking quality but increases confirmation failures, the decision is rollback, not a weighted average that hides the failure. Novelty and interference can distort the comparison. Early traffic may contain novelty effects. Users, support staff, or downstream systems may behave differently when a changed result layout or ranking order is first introduced. Conversely, a candidate may appear weak because users have not yet adapted to a useful interaction. Mark exposure time and inspect trends rather than treating the first few observations as the final estimate. Interference also matters. Users can share listings, agents can respond to demand, inventory can change, and a successful booking can remove an option from later searches. One request treatment can therefore affect another request's outcome. A user-level assignment reduces switching but cannot eliminate market effects. Search traffic split by request is not automatically independent evidence. For high-impact changes, document the likely interference path and interpret the result as evidence for the tested rollout design, not a universal property of the re-ranker. A candidate can improve ordinary city queries while mishandling a sparse rural query with only 2 eligible listings. So aggregate search success may rise while that slice loses the only qualifying property from the top result. The canary should block promotion if the slice is protected by policy or if the resulting confirmation task fails, even when the overall metric improves. If the slice is too rare for a reliable online estimate, keep it as a targeted offline and human-reviewed release gate rather than claiming that the canary cleared it. Next, focus on the release artifact. Update the release manifest, not merely the dashboard. It should name the candidate and control versions, the preceding offline gate result, The canonical confirmation contract version, eligibility, and assignment rules. The primary task success metric, secondary quality metrics, operational guardrails, strata, sampling policy, rollback thresholds, owners, exposure window, and links to retain traces. Add the canary comparison report to the pull request or deployment record. If an incident occurs, preserve the trace, reproduce the failure in the assistant sandbox, reduce it to a version regression fixture, and add that fixture to the appropriate CI tier before retrying deployment. The comparison program belongs in the companion repository and imports the established trace contract and fixtures used by the earlier evaluation sections. The repository's shared trace record contains stable cohort, stratum, outcome, guardrail, and redaction fields, while canary_fixture and redacted_trace are pinned, synthetic fixtures. The adapter selects only the fields needed for the report, so a production trace schema change fails at the import or attribute boundary rather than silently changing the meaning of the example. This program summarizes validated trace record rows by cohort and stratum, then compares canary with control where both cohorts exist. It imports the shared trace record, canary_fixture, redacted_trace, and redact_trace, and permits only control or canary cohorts and ordinary or sparse strata. Validation rejects unknown cohorts, invalid strata, and missing evaluation fields before rows enter a denominator. Summarization counts rows, successes, and guardrail breaches and returns sample size, success rate, and guardrail breach rate. Comparison adds success rate and guardrail breach rate deltas only for match control and canary strata. The executable tests cover missing contemporaneous control, invalid strata, redaction before retention, and incomplete evaluations. The main block prints the comparison and then reports 4 past tests. The companion repository supplies the imported objects and runs this file with the pinned dependency lock file. Trace record is the shared schema rather than a second outcome definition. Canary_fixture is the repository's deterministic, synthetic control / canary fixture, and redact_trace is the same redaction component used by the online sampling path. The 4 tests make the safety properties executable. A cohort with no contemporaneous control produces no delta. An unknown stratum fails closed. Direct identifiers are removed before retention, and incomplete evaluations never enter a denominator. For the pinned fixture, the exact report printed by the program is provided next. The report shows ordinary canary success at 1.0 versus control at 0.5, producing a positive 0.5 success delta, while the guardrail breach rate delta is 0.0. For sparse, canary success is 0.5 versus control at 1.0, producing a negative 0.5 success delta, while the guardrail breach rate delta is 0.5. The report then states that 4 tests passed. The artifact reports strata and guardrail deltas, not a winner. Both the ordinary query success delta and the sparse query guardrail breach delta are 0.5, so aggregate or ordinary query improvement alone does not justify promotion. Missing cohort, invalid stratum, redaction, and denominator tests protect the evidence contract. These tests belong alongside shared schema and deployment gate tests. This evidence supports a controlled rollout decision for the measured traffic, confirmation contract, and release design. It cannot establish universal correctness, settle unmeasured rare harms, remove confounding from interference or novelty, or justify a domain policy conclusion without qualified review. AI engineers maintain the release manifest and regression fixtures. Evaluation engineers maintain scores and strata. Platform engineers preserve routing and trace integrity. Product engineers define meaningful task outcomes. And safety engineers own intolerable event criteria. The production skill is making the decision reversible, inspectable, and able to produce the next regression test. The takeaway is a complete incident-to-regression cycle. Pass the offline gate, Deploy the re-ranker to a small, eligible cohort. Compare it with a contemporaneous control on the canonical search-to-confirmation task. Monitor secondary quality and operational guardrails. Roll back on pre-committed breaches, and encode every confirmed failure before the next attempt. A canary is valuable because it limits exposure while generating evidence, not because 5% makes an uncertain change safe by itself. Drift and evaluator drift. A new marketing campaign changes how buyers describe homes. Flex room replaces home office. Multi-generational layout appears where users previously said in-law suite, and a wave of short, mobile written requests removes the location details the assistant normally relies on. The demo improves because the assistant now sounds fluent in the campaign's language. At the same time, confirmation behavior deteriorates. It begins treating ambiguous phrases as settled requirements, and the judge, trained on older examples, scores the new answers as helpful. The practical consequence is immediate. A green dashboard can coexist with worse decisions for the newly arriving traffic. Drift is a change in the evidence contract. Drift is not one phenomenon. In the real estate assistant, at least 4 things can change. Input drift. The distribution of prompts, languages, lengths, intents, locations, or requested property attributes changes. Behavior drift occurs when the assistant's observable behavior changes, including its answers, tool calls, confirmation rate, refusal rate, citation pattern, or escalation behavior. Label drift occurs when human judgments change in meaning or frequency. New user intents may appear, or policy may redefine which answers are acceptable. Evaluator drift occurs when a measurement instrument changes even if the assistant does not. Changes to a judge prompt, rubric, model, parser, sampling rule, or aggregation job can alter the score. These changes matter because an evaluation result depends on its traffic, labels, system version, and measurement procedure. Monitoring must therefore check both whether the score changed and whether the conditions that made that score interpretable still hold. Monitor traffic in slices rather than relying only on aggregate volume. The production trace should retain privacy-reviewed, access-controlled fields needed for analysis. Contract version, model and provider identifiers, policy version, tool outcome, task outcome, when available, judge version, human review status, and course analysis slices. Raw property details in user text should be minimized, redacted, or retained only under the approved data contract. A useful traffic monitor reports counts and proportions across stable slices, such as intent, language, channel, tool use path, confirmation state, and outcome availability. It also flags new or disappearing categories, missing fields, and denominator changes. A larger share of one request type is not, by itself, evidence of degradation. It identifies where the team should sample and label. Choose slices before looking for a convenient story. Overall helpfulness can conceal failures in ambiguous requirements or among users receiving a tool-generated property shortlist. Very small slices can instead create noisy alerts and unnecessary rollback. So use minimum count rules, stable sampling windows, and explicit insufficient evidence states rather than treating every percentage as equally informative. A sharp rise in unfamiliar buyer language together with fewer explicit confirmations signals that the requests need triage. It does not yet establish the cause. Judges should be recalibrated against fresh human labels rather than treated as oracles. An automated judge is an instrument, not an oracle. Its rubric can stay the same while the answer population changes. To detect evaluator drift, periodically draw a stratified sample of recent traces, have qualified humans label them using the current rubric, and compare those labels with judge decisions. The sample should include ordinary traffic, newly emerging slices, borderline cases, and known high-risk cases, not only easy successes. Recalibration can trigger when agreement falls below a pre-committed threshold, disagreement concentrates in a slice, the judge's pass rate changes without a corresponding human label change, or the rubric or judge implementation changes. Possible remedies include revising the rubric, adding examples, changing the judge, fixing a parser, or using temporary human review. A judge rationale can help locate disagreement, but it is not proof of correctness or access to private reasoning. In the campaign, reviewers find that flex room often means a room usable for several purposes, not necessarily a dedicated office. The judge rewarded confident answers that infer office. Fresh labels expose that failure, so recalibration must add the new language and the required clarification behavior to the evaluator's test set. Production scores need version context for the providers, models, policies, and contracts involved. Every production score needs a version context. Record the application release, provider and model identifier, prompt or policy version, retrieval configuration, tool schema, judge version, label rubric, and sampling configuration. Keep provider-specific adapters outside the durable evaluation core, and do not embed volatile behavior or pricing assumptions in how a result is interpreted. A behavior change after deployment may come from the application, a provider update, retrieval index changes, policy edits, or a judge change. Without a release manifest, these causes are easily conflated. The manifest should make each change queryable and link it to the affected fixtures, canary window, and rollback decision. Separate genuine behavioral drift from defects in the measurement path before changing the model. Before changing the model, verify the measurement path. Rerun a fixed fixture through the current scorer, compare raw trace counts with ingested counts, inspect missing labels and duplicate events, verify unchanged slice keys, and confirm that the numerator and denominator retain the same contract. A pass rate jump with unchanged outputs may indicate malformed results being accepted. A traffic shift may be a routing or logging defect, and a judge regression may result from a truncated prompt rather than change of system behavior. Use the established, normalized slice distribution interface from the shared trace schema and version fixtures. It validates the distribution contract, detects every current-only cohort as new even when its share is small, detects material changes, and emits a judge review trigger. Its tests cover empty cohorts, missing cohorts, new slices, threshold boundaries, invalid proportions, and denominator integrity. This code provides deterministic triage signals for normalized shared schema slices. It validates the baseline and current distributions, bounds each share between 0 and 1, requires each distribution to sum to 1, identifies new and missing cohorts, marks shared slices whose change meets the inclusive threshold, and requests judge recalibration whenever any of those signals occurs. The shared trace aggregator performs redaction and denominator accounting before this module is called, and this module does not store raw user text. The tests cover new small slices, the inclusive threshold, missing slices, and invalid distributions. The executable block produces the review signal and runs the tests. The expected report marks both existing slices as changed, reports no new or missing slices, and sets recalibrate_judge to true, followed by passing test cases when the repository test command runs this module. A small current-only cohort is reported as new and still triggers review because the threshold applies only to slices present in both distributions. Treat the result as a review trigger. Sample fresh traces and human label them. It is not a promotion or rollback decision by itself. The shared trace aggregator must enforce the approved redaction contract and compute shares from a common denominator before calling this function. Companion tests should use shared fixtures to verify redaction, missing cohort fields, duplicate events, delayed labels, denominator integrity, and score compatibility. pin dependencies, and clean environment execution remain required. This deterministic shared difference trigger is not a statistical drift test. The campaign loop monitors traffic for the new language, uses human review to expose, judge disagreement, identifies the prompt policy change in the release manifest, and uses instrumentation checks to rule out a logging defect. The online sampling policy adds the emerging slice. The judge calibration fixture adds confirmed examples and counterexamples, and the release manifest records the revised policy and evaluator versions. The next canary uses those fixtures and watches confirmation behavior directly. A change distribution is not automatically harmful. Seasonal, clearly labeled rental questions can shift slices while quality remains stable. Unchanged traffic does not guarantee safety because a silent tool failure or parser defect can damage behavior without changing the input mix. Drift evidence supports investigation, targeted sampling, recalibration, and, when paired with confirmed quality or guardrail deterioration, a controlled deployment decision. It cannot establish universal correctness, identify causation without controlled evidence, or replace domain review of sensitive real estate outcomes. These duties are operational work. AI engineers maintain version contracts and regression fixtures. Evaluation engineers maintain sampling, scores, and calibration sets. ML platform engineers preserve trace and routing integrity. Product engineers define meaningful outcomes, and safety engineers set escalation criteria. A sustainable system treats drift detection as a shared production interface rather than a dashboard owned by one team. Distinguish changes in inputs, behavior, labels, and measurement instruments. Verify the instrumentation, refresh human labels, record provider, and policy context, and then decide whether to recalibrate, investigate, roll back, or continue observing. The evidence should state what changed for which traffic, under which evaluator, and what remains unknown. The incident is converted into a regression test. A one-line prompt change made a real estate assistant sound more helpful, but caused it to edit a buyer's calendar without confirmation. The response is not merely to revert the prompt. It is to turn the unauthorized edit into a privacy-safe, causally diagnosed fixture family that blocks recurrence without freezing legitimate scheduling. Preserve the evidence before repairing the behavior. Start with the smallest evidence package that can explain the event. The user request, relevant conversation turns, retrieve policy or listing context, the tool selection decision, tool arguments, tool result, confirmation state, model and prompt versions, and the final user visible message. Remove names, addresses, phone numbers, email addresses, calendar titles, invitees, tokens, and unnecessary free text. Replace them with stable placeholders such as user_a, listing_17, and event_3, retaining relationships and data types rather than identities. Store the original trace under approved access controls and create a sanitized derivative for evaluation. Record who performed the transformation, what was removed, and whether the fixture is synthetic, production-derived, or hybrid. Do not copy an entire transcript into a shared test repository merely for convenience. For this incident, the redacted evidence package might contain the elements that follow. The user request is, put the inspection on my calendar. The event state was proposed. The confirmation value was false. The operation was create. The tool name was calendar.create. The tool arguments specified time 10 o'clock and listing ID listing_17. The guard allowed the operation. A mutation was observed. The tool reported success. The final message reported that the inspection was on the calendar. Because these values are controlled, they do not change the causal pattern. The investigation should locate the first causal failure, not merely describe the incident outcome. The incident outcome is not necessarily the first defect. Trace the decision path in order. Trace the decision path through 5 checkpoints in order. Request interpretation. Was a user asking for information, a proposal, or an action? Canonical confirmation contract. Was explicit confirmation required before a committing calendar mutation? Planning. Did the planner select a mutating tool prematurely? Enforcement. Did the calendar adapter reject an unconfirmed mutation? Response. Did the assistant accurately report what happened? Retain the specified evidence at each checkpoint. Classified intent and conversation state. Contract and policy version. Tool decision and arguments. Guard result and tool call outcome. And final message and event status. The canonical confirmation contract requires explicit user confirmation before a proposed appointment can be committed to a calendar. An existing event must be uniquely identified before an update. Reads do not mutate, and a draft or hold is permitted only when the tool contract explicitly defines it as non-committing. Calendar policy is separate from messaging or booking policy. Sending a message, submitting an offer, and changing a calendar are different actions with different authorization requirements. If the revised prompt says be proactive and complete tasks whenever possible, the first causal failure may be the planner treating a proposed appointment as confirmed. It may instead be a missing enforcement check in the calendar adapter. If the planner marked the action pending, but the adapter ignored that field, the regression must target the contract boundary rather than prompt wording alone. First, reduce the incident to a fixture, then use it to build related cases. The minimized fixture retains only what is needed to reproduce the invariant violation. This fixture records the unauthorized calendar mutation and the blocking gate. One exact prompt is a memory aid, not a robust regression suite. Expand it across direct versus indirect requests, explicit versus ambiguous confirmation, existing versus proposed appointment, one-turn versus multi-turn context, rescheduling versus creation, uniquely identified versus ambiguous events, and successful versus rejected sandbox responses. Include paraphrases and realistic noise, while keeping the expected policy outcome explicit. The fixture family should include the following cases. This case tests whether a proposed time is kept from mutating the calendar until confirmation is obtained. This case tests that explicit confirmation permits the sandbox mutation. This case tests that a details request avoids a mutating tool call. For move my existing inspection to 10 a.m. without a uniquely identified event, request disambiguation rather than guessing. If a tool response reports failure, do not claim that the event was created. For create a draft hold for the proposed inspection, permit only the explicitly non-committing draft contract. Use the boundary case to prevent overgeneralization. Treating every calendar-related request as forbidden would reduce usefulness and could hide whether the system honors its actual contract. Assert the required state transition, no underscore mutation, draft, or mutate, rather than searching for a phrase such as, "Are you sure?" The compact artifact uses shared repository schemas and evaluator interfaces when available. Its fallback classes and evaluator are test-only compatibility fixtures, not production schemas. No credentials or consequential tools are used. This artifact constructs regression fixtures from incident traces, derives the required contract transition, evaluates truthful reporting, and tests ambiguous mutation, confirmed updates, non-committing drafts, and failed tools. It first integrates shared repository schemas and a sandbox evaluator when available, using local compatibility fixtures only as a fallback. The contract definitions distinguish creating, updating, drafting, and reading. The transition logic permits a draft when a contract allows it, requires no underscore mutation for reads or non-mutating contracts, and permits mutation only when confirmation, event identification, and the guard allow it. Fixture construction redacts email addresses and phone numbers, records policy and contract versions, and preserves observed mutation, guard, tool success, and final message evidence. The local evaluator checks transition agreement and truthful reporting. The tests block an incident that mutated without the required transition, allow a confirmed existing event update, preserve a draft as draft, and require failed tools not to claim success. The artifact separates the redacted evidence package, minimized fixture, expected assertion, and operational destination. The original case is a blocking no underscore mutation side effect fixture. The confirmed existing event case protects mutate usefulness, and the draft case remains distinct. The evaluator checks that failed calls are not described as successful and that successful observed mutations are not reported as failed. In a repository, run the fixture through the shared scorer and sandbox evaluator, not only the local test double. Expected local output is 4 passing tests. The result validates fixture construction and reporting checks, not a deployed model's complete correctness. Pin the Python environment, add schema validation, review redaction output, and execute the candidate against both the old and new versions. Recurrence work combines verification, gating, control deployment, and ongoing monitoring. The candidate must eliminate unauthorized mutations, preserve confirmed mutations, permit only explicitly non-committing drafts, and accurately describe rejected or failed calls. Compare listing search, appointment explanation, and non-mutating calendar questions, so added caution does not cause unrelated regressions. Put the incident fixture in the blocking tier because it tests a high-impact, unauthorized side effect. Run representative paraphrases, read-only cases, and ordinary scheduling examples in the broader regression tier. Exploratory variants can inform review without blocking. The gate must identify the fixture, canonical confirmation contract version, required transition, and truthful reporting assertions. Deploy through a canary or similarly controlled slice. Under a documented privacy-safe policy, oversample tool calls, confirmation boundary cases, errors, and high-impact workflows while retaining a baseline sample for ordinary traffic. Monitor calendar mutation rate, confirmation state violations, tool failures, user corrections, and the incident signature. Link alerts to the fixture family and the deployed policy, prompt, model, routing, and contract versions, not only to a dashboard count. If recurrence appears, preserve the new trace and determine whether it is the same causal failure or a new boundary. Extend the family only after review. Offline success followed by canary failure supports rollback or containment while investigation continues. Neither outcome proves the prompt is the sole cause, universal safety, or absence of risk, because rare events, uninstrumented paths, redaction mistakes, evaluator blind spots, and changing traffic can limit the conclusion. For the cumulative real estate assistant, the changing artifacts are the version regression fixture family, the canonical calendar confirmation contract, the incident record, and the deployment gate configuration. Together, they make one unauthorized calendar edit durable institutional memory without conflating calendar, messaging, and booking policies. AI engineers diagnose traces and implement fixes. Evaluation engineers curate variants and thresholds. ML platform engineers preserve provenance and sampling. Product engineers define acceptable confirmation flows. And safety engineers decide escalation and containment. Their evidence supports whether a candidate may proceed under specified safeguards or needs rollback and further work. It cannot certify the whole application, replace domain review, or establish correctness from an LLM-Judge's explanation. The practical loop is redact the trace, locate the first causal failure, minimize and expand it into representative fixtures, Verify the expected transition in a sandbox. Place the assertion at the correct gate, canary the change, and monitor recurrence. A production failure becomes durable learning only when the repository, deployment gate, and monitoring policy all retain it. The continuous improvement flywheel moves from a production incident through privacy-safe redaction, causal diagnosis, minimized and representative fixture creation, sandbox verification, gate placement, canary deployment, and recurrence monitoring. A monitored recurrence loops back to incident review. This is a loop rather than a one-way release process. Monitoring supplies new evidence, and each reviewed boundary becomes another version fixture or contract assertion. An alert does not necessarily prove causation. The loop shows how evidence can produce a tested change through a controlled path. Production readiness review. A one-line prompt change can make the real estate assistant sound more helpful in a demo while stopping it from asking for confirmation before sending a viewing request. If released, the polished response can conceal an unauthorized external action. The launch checklist must establish decision ownership, examined evidence, how to stop the release, and which risks remain explicitly accepted. The launch decision is an evidence packet. For the assistant, readiness is a version packet rather than a single score. It identifies the candidate build, prompt and model configuration, retrieval and tool contract versions, dataset snapshot, evaluator versions, test results, owners, deployment stage, rollback target, and residual risks. Each result needs provenance. The cases run, sandbox conditions, assertions, and whether human approval was required. The packet supports a bounded decision. The candidate may enter the stated deployment stage under specified safeguards. It is not certified general correctness. A passing offline suite cannot establish representative traffic, complete evaluator coverage of harmful behavior, or identical external tool behavior between the sandbox and production. For the cumulative real estate assistant, the changing artifact is the launch manifest and readiness report. Regression fixtures from the previous incident remain inputs. The manifest binds them to the candidate, required confirmation assertions, the canary plan, and the rollback version. The report should fail closed when a required artifact is missing instead of silently treating missing evidence as a pass. The final packet should also verify that the system's planned delivery and learning assets are assembled. Add these entries to the launch checklist. The checklist covers 4 assets. For the 3-tier CI strategy, record the evaluation or platform owner, a version policy or repository revision, evidence that pull request, merge, and scheduled suites were exercised with blocking or non-blocking dispositions, and the accepted risk that slow or expensive checks may run after merge or on schedule. For the GitHub Actions workflow, record the ML platform owner, workflow commit or release tag, evidence of a clean pinned run that produced the readiness artifact and failed closed on missing or failed required checks, and the risk that hosted runner outages or dependency changes may delay evidence. No release proceeds without a valid artifact. For the online sampling policy, record the observability or evaluation owner, policy revision and effective date, evidence that sampling, segmentation, redaction, retention, access, and escalation were reviewed against the canary plan and tested with sandbox traces, and the risk that unsampled traffic and privacy-preserving redaction can hide rare failures. For the incident playbook, record the safety or operations owner, playbook revision and effective date, evidence that pause, rollback, tool capability revocation, trace lookup, notification, and incident to regression steps were exercised in a sandbox or tabletop review, and the risk that a new failure may not match an existing trigger and may require human judgment. Owner, version, verification result, and residual risk are mandatory. A missing entry is an unknown, not an implicit pass. For the assistant, these entries connect the 3-tier gate to GitHub Actions execution, online observation during the canary, and the incident to regression process. Evidence must be validated before the gate, is trusted. Record the fixture source, inclusion rules, consent and redaction status where relevant, domain coverage, language and channel mix, and the boundaries of synthetic examples. Check for duplicates across training, tuning, and evaluation material. A convenient fixture set may still be unrepresentative. A suite dominated by straightforward property searches may say little about ambiguous ownership, sensitive user attributes, stale listings, or a user changing their mind after a tool call. Every evaluator needs a stated target, inputs, expected behavior, and known blind spots. Exact assertions fit confirmation gates, tool arguments, authorization state, and schema validity. Rubrics or model-based judges can help triage open-ended quality, but their rationales provide evidence about the evaluator's judgment, not proof of correctness or observable private reasoning. Sample disagreements for human review. Preserve evaluator versions, and check whether a score improves by exploiting a rubric instead of improving behavior. Record both coverage and counterexamples. If the assistant correctly asks, "Would you like me to request a viewing for Tuesday at 4 p.m.?" and the user first approves, a later, "Actually, don't send it," must be treated as a state transition rather than reusing the earlier approval. If a tool claims the request was sent, but the sandbox contract reports a timeout, replying "done" must fail even when the prose is fluent. These cases prevent a confirmation metric from being generalized into a claim that all tool-mediated consent is safe. The manifest should state which tools are sandboxed, which user identity field are trusted, what freshness guarantees retrieval provides, what happens on timeout, and which traffic segments are excluded from the evidence. Unknown is a status worth recording because it is safer than turning an unmeasured path into a green check. Operations must be included as part of evaluating a candidate, not treated as a separate concern. Before approval, dashboards must show both quality signals, such as confirmation compliance, valid tool arguments, retrieval grounding, escalation, and sampled human review, and operational signals such as errors, latency, timeouts, tool failures, queue depth, and rollback health. Important signals should be broken down by release, route, traffic segment, and tool. Alerts need an owner, a threshold or detection rule, a severity, and a response window. An alert without a runbook is merely a notification. The incident path should specify who can pause the canary, who can revoke a tool capability, where traces are redacted and stored, how affected requests are identified, and how product, support, and safety decisions are coordinated. Consequential actions should remain behind the established sandbox and approval boundaries during validation. Approvals should also be explicit. A product owner may accept a user experience trade-off. An evaluation owner may attest that the required suites ran. A platform owner may confirm observability and rollback, and a safety or domain reviewer may be required for a sensitive workflow. These roles need not be different people in a small team, but the responsibilities must not disappear into an informal looks good. For the assistance canary, the checklist requires the new candidate and rollback candidate to be deployable, the confirmation regression fixtures to pass, dashboards to receive traces with appropriate redaction, and the alert route to be tested in the sandbox. The canary proceeds only with a defined stop condition. If confirmation compliance falls, tool failures rise, or a new incident appears, the response is pause or rollback first, investigation second, not an argument that the aggregate score remains acceptable. The 4 asset entries above must also be green or explicitly marked unknown with an owner and mitigation before approval. An unverified workflow, sampling policy, or playbook is not evidence that the corresponding control exists. Record gaps and schedule the next review. Residual risk belongs in the launch record. Write the gap, affected behavior, current mitigation, owner, decision impact, and next review date. More data needed is not sufficient. Specify which traffic or scenario is missing and what evidence would change the decision. A known limitation may be acceptable for a constrained canary and unacceptable for broad release. The real estate assistant might launch with an unresolved gap around rare multi-turn changes to a viewing request. The mitigation could be a disabled automatic send path, mandatory confirmation, trace sampling, and human escalation. The next review should revisit recurrence, sampled transcripts, evaluator disagreement, and any new tool contract failures. If no owner or date exists, the gap is not being managed. It is being deferred invisibly. The readiness report connects daily engineering responsibilities. AI engineers repair prompts, routing, and tool handling. Evaluation engineers maintain fixtures and adjudicate disagreement. ML platform engineers preserve lineage, sampling, and rollback mechanics. Product engineers define acceptable confirmation flows, and safety engineers assess escalation and containment. The report gives all of them a shared object. A deterministic readiness report. The companion artifact below deliberately reads, manifests, and test results rather than contacting providers or consequential tools. Its durable core is a small JSON contract. Required checks have names and statuses, and the report records missing or failed evidence deterministically. Provider-specific adapters can produce the input files without changing the gate. Duplicate names are rejected rather than normalized. Conflicting evidence must be repaired by its producer, not silently resolved by the gate. The code reads manifest and results JSON, validates the candidate, required checks, duplicate names, and statuses, then builds and renders a deterministic report. Missing checks are unknown. Readiness requires every required check to pass. The command writes to standard output or output and returns 0 for ready, 1 for a valid report that is not ready, and 2 for read, validation, or write errors. The implementation rejects duplicate required names and duplicate observed names before constructing the report. This is deliberately stricter than last result wins. A producer that emits conflicting evidence must fix the artifact. Output write failures receive the same controlled command line treatment as malformed input and return status 2, while a valid report with failed or unknown checks returns status 1. Save the preceding block as readiness_report.py. The following standard library test module is executable with Python. munitist vtest_report. It supplies the required validation rather than merely suggesting that tests be added elsewhere. The test module validates all pass, failed, and missing checks, duplicate names in both inputs, malformed status data, and a controlled output error. It calls build and report directly for report and validation cases. The output error test creates temporary files, supplies, output through sys_rgv, calls main, and asserts status 2. The tests cover malformed status data, missing and failed checks, duplicate names in both input forms, an all-pass report, and an unwritable output path. In a pinned, clean environment, the expected test result is 5 passing tests. The output path test also verifies that no traceback is required for an operational file system failure. The readiness CLI example itself remains deterministic, with a manifest requiring confirmation or regression, tool_contract, and rollback, and results marking the first 2 pass while omitting rollback. The output is. This packet records check statuses and sets readiness to false while rollback is unknown. The non-zero result and explicit unknown prevent an incomplete packet from entering the next stage. The code verifies artifact completeness and statuses, not evaluator validity, ownership completeness, rollback mechanics, privacy controls, or residual risk acceptance. It does not prove that evaluators are valid or decide whether a domain risk is acceptable. It enforces the narrower decision that required evidence is present and passing. Broader judgments still require manifest review and named approvers. Production evaluation is a feedback system connecting releases, real behavior, incidents, and future tests. A canary is complete only when its quality and operational signals are visible, its owners and rollback are known, its floor-plan control assets are versioned and verified, and its gaps have dates. When the next incident occurs, the packet gains a redacted trace, a diagnosed fixture, a revised evaluator or contract, and a new gate. This turns a launch checklist into an operating system for reliability rather than a one-time approval ritual.